हेलो एवरीवन, मैं प्रोफेसर माखन सिंह चौधरी इस संस्थान में गणित विभाग में प्राध्यापक हूँ। आज हम लोग कैलकुलस के कॉन्वेक्सिटी एंड कॉन्केविटी टॉपिक पर चर्चा करेंगे। इस टॉपिक से संबंधित जानकारी आपके सामने प्रदर्शित है। के बाद टेबल ऑफ कंटेंट, यानी आज चर्चा के जो सीक्वेंस होगा, सबसे पहले लर्निंग आउटकम्स पर चर्चा करेंगे, लिंक टू प्रीवियस टॉपिक, इंट्रोडक्शन, definition and example of convexity and concavity, test for convexity and concavity, and finally summary, and then assignment, references and links to further readings. Let us discuss learning outcomes. After studying this module, you will be able to remember the definition of convex and concave sets and also functions. Understand the concept of convexity and concavity and point of inflection. Analyze the curve and classify them on the basis of convexity. Evaluate the point of convexity, concavity, and point of inflection. And you will be able to apply the concept of convexity and point of inflection in your daily life. You will also be able to create the convex and concave curves. Now, link to previous topics. You have the knowledge of geometry, continuity, and also differentiability. Now, let us introduce the concept. In mathematics, the concept of convexity and concavity are fundamental properties that describe the curvature and shape of the functions, sets, and geometric objects. They play a crucial role in optimization, calculus, and various areas of mathematics and its applications. The word concave is derived from the word cave, which means the shape of object is curved inward or inside. This is the example which is taken from the Shutter stocks. This is the cave. This shape is curved, and this is the concave curve. This is also mathematical shapes: concave curve, concave shape, and convex shape. A set of geometric objects is called convex or concave upward if any 2 points within the set on the object, the line segment connecting these 2 points, lie entirely within the set or the object itself. Mathematically, a set is a convex if any 2 points x and y in S and any real number t in the interval 0, 1, the point tx plus 1 minus t into y also belongs to S. This is the convex shape. A set or geometrical object is concave if some portion of the line joining to the curve of the set goes outside the set. It is the opposite concept of concavity. In concave shapes, at least 2 sides are pushed inward. This is concave shape. This is also concave. Mathematically, we can define the concave set. as if any 2 point xy in S and any real number t in the interval 0, 1, the point tx plus 1 minus t into y does not belong to the set, then it is concave. Now let us discuss the convex functions and concave functions. A function fx defined on an interval I is called convex for any 2 points x1 and x2 in I and any point t in the interval 0, 1. The inequality f of t x1 plus 1 minus t into x2 is less than equal to t into f of x1 plus 1 minus t into f of x2 is true. If this expression is true, then function t is called convex function. Let us see in the graph. This is the function. This is the line intersecting the curve. So A, B and middle point at plus 1 minus t into bt. Let us see the images of A. This is the FA, this is FB, this is f of ta plus 1 minus b, and this is t into fa plus 1 minus f. So geometrically a function is said to be concave if its graph lie between the chord connecting any 2 points on the graph as it has seen in earlier graph. Now let us discuss the definition of the concave function. A function fx defined on an interval I is called concave if any 2 point x1 and x2 in I and any point t in the interval 0, 1, the inequality f of t x1 plus 1 minus t into x2 greater than equal to, just opposite to the convex function, greater than equal to t into f of x1 plus 1 minus t into f of x2 is. Let us see in the graph. This is x-axis, y-axis. This is the curve, given curve. This is the line connecting 2 points A and B. This is the middle point. Now let us see the images. This is FA. This is FB. This is T into FA plus 1 minus T into FA. And this is F of TA plus 1 minus T into B. So here T into Fa plus 1 minus T into Fa becomes lesser than the f of T into A plus 1 minus T into V. This is the just opposite to the earlier graph. Geometrically, a function is said to be concave if its graph lies above the chord connecting any 2 points on the graph. Now, let us another definition of point of inflection. A point P on the graph of the function fx is called point of inflection if the function is convex on one side of the point and concave on the other side. So this is the dual nature. Just see in the graph. This is the x-axis, y-axis, origin. This is the graph. So see, this P point divides the curve into two parts. One part is convex and one part is concave. So this P is the point of inflection. Now let us check the concavity and convexity with respect to x-axis mathematically. Up to we have checked geometrical and graphical representation of the concept. Now let us check it by mathematically. Let P of xy be any point on the curve y equal to fx. Then a function is convex if its slope is non-decreasing. If we calculate the slope and if it is non-decreasing. Another test for convexity, you can also calculate it by y into second derivative of y with respect to x. This is greater than equal to 0, then curve will be the convex curve. It is strictly convex curve. The test is same, but strictly greater than sign appears here. This is the strictly greater than sign. Remaining is same. Similarly, a function is concave if its slope is non-decreasing, just opposite to the convexity. And also you can calculate it by um, multiplying y with its second derivative with respect to x, which should be less than equal to 0. Then the curve is concave. It is strictly concave if its slope is continually increasing, or y d2y by dx square is less than 0. And a point on the function y equal to fx is a point of inflection if second derivative is 0 but third derivative is not 0. Then you can calculate the point of inflection mathematically. Now another concept, point of undulation. If the second derivative, third derivative, fourth derivative and n minus first derivative equal to 0 but nth derivative not equal to 0, then there would be a point of inflection if n is odd. But if n is even, then curve does not cross the tangent. Such point, if n is greater than 2, is called the point of undulation. So you can calculate it by the. Now similarly, we have check the convexity and concavity with respect to x-axis. Now let us check this concept with respect to y-axis. This needs when curve is parallel to y-axis. So we can interchange x and y, then we get the result as x into second derivative of x with respect to y is positive or negative at p. So we get the result. Similarly, point of inflection, second derivative equal to 0 but third derivative not equal to 0. So this is the point of inflection. This test is useful when the tangent at p is parallel to the axis of y. Let us understand this concept by some examples. Example, y equal to e to the power x. Check this function for convexity. As earlier we have learned that if we get the second derivative and second derivative is e to the power x, which is always greater than 0. So multiplication of y into second derivative also becomes greater than 0. So this curve is strictly convex function. Second example, find the point of inflection of the curve y equal to x to the x cube. So you can find the first derivative equal to 0, second derivative equal to 6x. Also point of inflection, we get x equal to 0. So y equal to 0 at x equal to 0. Third derivative not equal to 0. Therefore 0 is the only point of inflection of this curve. Now let us discuss the summary up to we have discussed. In this chapter we have discussed what we have discussed: learning of the learning outcomes, link to previous topics, introduction, definition and example of convexity and concavity, test of convexity and concavity. Now you can see the references for further readings. These are the references, links, online links. You can read this topic on in these links. Now let us assessment. Let us assess your knowledge. Curve y equal to x to the power 4 minus 6 x cube plus 12 x square plus 5x plus 7 is concave in the interval. Check it. This is the answer. 0, 1 is the answer. So let us take the second question. If minus 1, 2 be the point of inflection of the curve fx equal to ax cube plus bx square, then the values of a and b are, you can check this. So thank you very much for being with us. in this topic. Thank you.